to my session about building resilient cloud services with .NET 8. And in the next 25 minutes, I will be talking about our cooperation with the open source community in creating the new Poly V8 version. And I will be also demoing these new resiliency features and the new resiliency libraries that we are introducing as a part of .NET 8. So when in the cloud world or when communicating with remote cloud services, one thing is certain, and that failures will happen. And these failures can happen either due to a network outage or transient errors on the server side, or in the more serious scenarios, the remote service outage when we are not able to communicate with service for an extended period of time. And the resilient cloud service is able to anticipate this error, can recover from them, and can adapt to the change conditions due to these failures. It's impossible not to mention the Poly, the .NET Resilience library, when talking about the resilience, because it is the most popular .NET Resilience library, and it allows us to enhance the system stability and resilience. It also handles the transient failures, and it can help protect our system resources. The Poly offers a variety of resilience strategies or policies, for example, the retry, circuit breaker, timeout, fallback, rate limiting, and more. I will be talking about these in the demo, but if you want to learn more, you can visit the Polydocs site where we explain all of these resilience strategies in detail. So what's the relation of Poly and Microsoft? And I can tell you we love Poly and we use it a lot because Poly is powering some of the largest scale cloud services that we use in the team space or in the office space. And we also use it to build both server and client application. And over the years, we have also built some internal resilience libraries on top of the Poly. And we added some features that were not available in Poly as a built-in feature. For example, the telemetry support, the dependency injection, or the options-based configuration. And over time, we saw the wide adoptions of these libraries. But we also encountered some limitations of Poly v7 API and design. And we also experienced some performance issues where there were some allocations on the hot path. So at some point, we sit down and started thinking about how we can expose these improvements back to the broader open source community and how we can improve the Poly itself. So what we did, we demoed the new proposed API to Poly community and maintainers, and it got a great feedback. So that's when the Poly V8 project started, and I think it was around March. And we worked on the Poly V8 for the better part of the year. And now, it's here. So the Poly V8 was released in September. And this is the result of collaboration between the Poly community and Microsoft. The Poly V8 offers the modernized API and simplified design. It also improves the performance and exposes new low allocation APIs for advanced scenarios where everybody is successful for you. It also offers the built-in native telemetry. It natively supports dependency injection. We also expose the new hedging resilience strategy. So in short, the hedging allows you to retry slow requests in parallel. But I will showcase the hedging in the demo. Also important to note is that the Poly V8 addressed many long-standing community issues that were simply not possible to be fixed or very hard to be fixed with the older design. And we also worked on the documentation, so you can visit the polydocs.org site, and we got many great contributions from the community that contributed the content for these docs. Let's take a quick look at the Poly V8 usage. So the central API is the resilience pipeline. The resilience pipeline can be created using the resilience pipeline builder. You use this builder to add one or more resilience strategies to the pipeline, and you can conclude by calling the build method. Once you call build, you get an instance of resilience pipeline, And you can use this object to execute arbitrary callbacks. So you can use the asynchronous callbacks, synchronous callbacks, or like anything that returns void or any type of result. The specialized scenario for the non-generic pipeline is the generic pipeline. So what we can see in this slide is the resilience pipeline of HTTP response message. The sample is very similar to the previous one. Maybe one notable difference is the should handle predicate that, and in this case, we are telling the retry strategy to retry exceptions and also on some results. So for example, we are retrying any internal server error or greater. And the usage is the same. The only difference is that this resilience pipeline only accepts callbacks that return the HTTP response message. So next, adding resilience to the HTTP client is a very common scenarios. So that's why we are introducing libraries that have dedicated resilience support for HTTP client. We offer seamless integration with HTTP client factory, and these new APIs are tightly integrated with Poly V8. So they also inherit some of the great features of Poly, like a low allocation API, improved performance, and it will be very easy to use for anyone that is familiar with Poly. And also, we also support new capabilities. And all these APIs are based around resilience pipeline of HTTP response message that I was showing off earlier. So the first library we are announcing is the Microsoft Extensions HTTP Resilience library. And this one is used to build resilience HTTP requests. As I mentioned earlier, it's built directly on top of Poly V8, and it offers API for creating and using the HTTP resilience pipeline, such as custom pipeline, standard pipeline, and standard hedging pipeline. We will demo these in a bit. And the other library we are announcing is Microsoft Extensions Resilience library. So this one is a really thin library. It just enriches the built-in telemetry of Poly with some new dimensions that you might find useful. And now let's go to the demo. So what I did, I prepared a very simple solution where I have a server application and the client application. If we explore the server application, it's just a single endpoint that exposes the weather forecast. So let's try to run it. And the client application is a console app that is using the iHTTP client factory to create an instance of HTTP client, and that client sends the request to my server. We sent 10 requests to the server, and we also track the latencies and the status codes and any exceptions that throw. So when I run the server in a bit, let me just type something here. .NET run. I don't know, for some reason the console window disappeared, but what we see, the latencies are great, the responses are great, we are getting 200, so everything is good. And this is because we are in the local environment, and the risk of failure is very, very low. But what we can do instead is to simulate the real world scenario, what we can do, we can inject some failures on the server side. So what I'm doing here, I am injecting request delays and exceptions. So there is 20% chance that the request will take more than 5 seconds, and there is 30% chance that the request will fail. Like hopefully no real service is this unstable, but for the purpose demo, let's go with these numbers and see what happens on the client. So I'm running client again. And now when I send the request, the situation is not so good anymore, because what we are experiencing is the increased latencies, 500s. Luckily, this is exactly the scenario where the new packages or new resilience libraries can help you. So what we can do, let's shut down the server, or the client, and let's add dependency to a new Microsoft Extensions HTTP Resilience package. So let's install it. Let's build our client application so we know everything works fine. And let's try to use the new APIs that are introduced in this package. So after we edit our named HTTP client, let's call @resilience handler. And this thing requires the identifier. So this the identifier for the resilience handler. So this will be used in the telemetry. And the other is the callback. And if we explore the arguments of the callback, this thing is the resilience pipeline builder of HTTP response message. So this is exactly the API I was showing off earlier. And what we can do now is we can start to add some new resilience strategies that will be applied to the HTTP pipeline. So what I can do first is to limit the latency of the request. So we want to reject the long requests. So this way we can preserve the both client and server resources. So what I can do is call @timeout, and let's say I don't want my request to take longer than 1 second. So let's run our client application again. .NET run and see what happens. And at this point, we should not be seeing requests longer than 1 second. However, we are still seeing 500s and the exception caused by the timeout resilience strategy. So this is a good place to introduce the retries to our pipeline. So let's call builder @retry. And let's use the HTTP retry strategy options here. Let's include the namespace. If we look at the definition of these options, these just derive from retry strategy options. So these are polyv8 options, but we derive from them and tailor the defaults for HTTP scenarios. So we don't have to set up all the stuff from beginning. But what we can do in our scenario is to increase the number of retry attempts from 3 to 5, because our server is quite unstable. So let's make sure our requests are successful by increasing the number of retries. Next thing what we can do is also we can change the amount of time that the retry strategy waits between the retries. This can be done by using the backoff type. So the default is exponential. I will just keep it as that. We can also add jitter to retries. And in the end, I can change the base delay that will be used for the retries. But for the purpose of the demo, I will just change it to 0 so we don't wait too much. If I run the client application again, run, we should not be seeing any 500s or issues because everything is automatically retried. We can see some increased latency. So for example, from this, I know that, okay, first request failed, but the second was successful and so on and so on. Now, let's try to simulate the outage of the remote service that we are connecting to. And for this, we can just shut down our server and see what happens now. We wait a little because the retry strategy and timeout is attempting to over and over send the request, but since the server is down, there is nothing this pipeline can do with it. So we still keep sending the requests. We still keep wasting the client resources or server resources. And at this point, this pipeline cannot do anything with this. What can help here is to integrate the circuit breaker. And circuit breaker is able to detect the outage in the remote service and is able to suspend all the communication to that endpoint for a period of time. Then it can try again and see if the issue is resolved. But to integrate the circuit breaker, what we can do is we can call @circuit breaker, and let's use the HTTP circuit breaker strategy options. So in general, like the options in Poly are used to define the behavior of the strategy. So in this case, let's fine tune the circuit breaker, and let's say our sampling duration is 5 seconds. seconds 5. I will explain this in a bit. Our failure ratio, let's change it to 0.9. Our minimum throughput is set to, let's say, 5. And duration of break duration is set to 5 seconds. So what this configuration tells the circuit breaker? And the idea is, over the sampling duration of 5 seconds, if you have a minimum throughput of requests of 5, and 90% of those requests are not successful, then the circuit breaker will open. And open circuit breaker means that there is no communication flowing out of the HTTP client. And that circuit breaker will be opened for a break duration of 5 seconds. After those 5 seconds, circuit breaker will allow a single request. We call it probing request. And if that request is successful, the circuit breaker is closed and the communication can flow again. So let's try how this pipeline behaves now. What we should see is that initially we should see a longer delay. So you see initially this correlates with the sampling duration of 5 seconds. And during this sampling duration, circuit breaker detected that the endpoint was not healthy, and it's simply broken it. And from now on, we see that all requests are very fast because there is no communication that flows out of the HTTP client. We can see occasional increase in latency. And this indicates the probing request. So probing request was sent, the server is still down, it was not successful, circuit breaker stays open, no communication can go out. So let's run our server now, again, and see how the pipeline, I was thinking that this should take longer, but the pipeline immediately recovered. Because the probing request sent from the HTTP client was successful and the communication can flow again. So if we review our pipeline now, we can see we have a custom resilience handler with 3 strategies. So there is retry, circuit breaker, and timeout. And for completeness, for our internal partners and for our recommendation is also add the overall timeout strategy. And this timeout applies across all the attempts. So there is, including all the attempts, we don't want our request to take more than 5 seconds. And also, additionally, to prevent against DDoS attacks, what we can do, we can add a rate limiting. In this case, I'm adding the concurrency limiter, and I am saying here that I will not allow more than 100 concurrent requests that can flow at any given point in time. And this is the pipeline, exactly. If you look at these 5 strategies, this is the pipeline that we recommend and we use in many of our internal services, and these are huge services. The thing is, typing this over and over again is time-consuming and error-prone, so that's why we have also introduced this standard resilience handler API that automatically incorporates these 5 strategies. There are sensible defaults. You can just use it as it is, unless you don't want to fine-tune the behavior. If you want to fine-tune the behavior, you can use the configure extension and change the options. And let me just copy and paste the options I have used in the custom pipeline. And if we run our sample, everything should work just fine. Now, what we got some really great pipeline that works just fine. But in some scenarios, you don't want to have these high latencies. And thankfully, we also have another API that can help you with these scenarios, and that is the standard hedging handler. So the standard hedging handler is the pipeline of this standard hedging handler is very similar to the standard resilient pipeline. The only difference is that instead of retries, the standard hedging handler uses the hedging. And what hedging does is that it retries slow requests in parallel. A very important note is that it should only be used for idempotent requests, so the requests that do not change the state on the server. And this is because you could get some into corrupt state, and because like the hedging by definition can send multiple concurrent requests at any given point. I will explain the configuration. Let me just paste the defaults or change the defaults. The rest is almost the same to the previous pipeline. The only difference here is the hedging. So previously we used the retries here, but hedging has very similar configuration to retries. But the delay, what it means for the hedging engine is that if you do not get a successful response after 50 milliseconds, send another concurrent request, and then raise those requests and pick the fastest successful one. If we run our application again, what we can see is that our requests are very, very fast. This is because the hedging kicks in and shields us from those slow requests. And the final thing I want to show in this demo is the telemetry that is built into the Poly and the new Resilience library. So to keep out the noise, I have turned off the logging, but let's just enable them now, and let's run our sample. And now you can get much more insights into what's happening inside the HTTP pipeline. So most of these logs are generated by Poly. We also have metrics, but I will not be able to show them. But what we can see the pipeline executions. We can see a resilience event. So for example, this hedging happened. So you might want to track, number of hedged attempts to see, how healthy is your dependency. And I think this concludes the demo, and I can just present the final slides to conclude the whole session. So the summary, what we have shown here. We have shown 3 APIs for HTTP clients. So first one is the add standard resilient handler. This should be your default choice when you need to add a resilience to HTTP client. It has been battle tested in many services, and it has sensible defaults. If the standard resilience handler does not work for you, and the latency is important, and you do not care about increased costs, and you can send multiple requests concurrently, you can use the standard hedging handler. And one important feature I have forgot to mention for standard hedging is the support for routing. So for a hedging handler, you can actually configure at what endpoints each attempt can go. So that way you can hedge against multiple servers. So if one server goes down, the hedging will automatically fall back to the secondary server or any amount of servers you want. And if both standard resilient handler and the standard hedging handler does not work for you, you can use the other resilient handler, which is used for building custom resilience pipelines, and you can tailor the pipeline to your scenarios. This is the API I was just showing off just for completeness. And if you want to learn more, you can visit the official documentation on the Microsoft site. You can also learn about Poly at polydocs.org. And if you want to contribute, go to the repositories of these extensions and the Poly. And thank you. That concludes my presentation. And back to you.